Yeah. Going back to Gemini, I'm curious what the bottlenecks were in the development. Like, why not make it immediately one order of magnitude bigger if like scaling works?
Well, look, first of all, there are practical limits. How much compute
Yeah, yeah.
that can you actually fit in one data
Sure,
center?
sure.
And actually, you're bumping up against very interesting, distributed computing kind of challenges, right? Where unfortunately we have some of the best people in the world on those challenges, and cross data center training, all of these kinds of things. Very interesting challenges, hardware challenges, and we have our TPUs and so on that we're building and designing all the time, as well as using GPUs. And so there's all of that, and then you also have to, the scaling laws, they don't just work by magic. You still need to scale up the hyperparameters, and various innovations are going in all the time with each new scale. It's not just about repeating the same recipe. At each new scale, you have to adjust the recipe, and that's a bit of an art form in a way. And you have to sort of almost get new data points. If you try and extend your predictions, extrapolate them, say several orders of magnitude out, sometimes they don't hold anymore, right? Because new capabilities, they can be step functions in terms of new capabilities, and some things hold and other things don't. So often you do need those intermediate data points actually to correct some of your hyperparameter optimization and other things, so that the scaling law continues to be true. So there's sort of various practical limitations onto that. Kind of one order of magnitude is about probably the maximum that you want to carry on. You want to sort of do between each era.
Oh, that's so fascinating. In the GPT-4 technical report, they say that they were able to predict the training loss, tens of thousands of times less compute than GPT-4. They could see the curve. But the point you're making is that the actual capabilities that loss implies, it may not be so clear.
The downstream capabilities sometimes don't follow from you can often predict the core metrics like training loss or something like that, but then it doesn't actually translate into MMLU or math or some other actual capability that you care about. They're not necessarily linear all the time. So there's sort of non-linear effects there.
What was the biggest surprise to you during the development of Gemini, of something like this happening?
Well, I mean, I wouldn't say there was one big surprise, but it was very interesting, trying to train things at that size, and learning about all sorts of things, from organizational, how to babysit such a system, and to track it. And I think things like getting a better understanding of the metrics you're optimizing versus the final capabilities that you want. I would say that's still not a perfectly understood mapping, but it's an interesting one that we're getting better and better at.
Yeah. There's a perception that maybe other labs are more compute efficient than DeepMind has been with Gemini. I don't know what you make of that perception.
I don't think that's the case. I mean, it's I think that actually Gemini 1 used roughly the same amount of compute, maybe slightly more than what was rumored for GPT-4. I don't know exactly what was used. So I think it was in the same ballpark. I think we're very efficient with our compute, and we use our compute for many things. One is not just the scaling, but going back to earlier to these more innovation and ideas. You've got to, it's only useful, a new innovation, a new invention, if it also can scale. So in a way, you also need quite a lot of compute to do new invention, because you've got to test many things at least some reasonable scale and make sure that they work at that scale. And also some new ideas may not work at a toy scale, but do work at a larger scale. And in fact, those are the more valuable ones. So you actually, if you think about that exploration process, you need quite a lot of compute to be able to do that. I mean, the good news is I think, we're pretty lucky at Google that this year, certainly, we're going to have the most compute by far of any sort of research lab. And, we hope to make very efficient and good use of that in terms of both scaling and the capability of our systems, and also new inventions.